when we're done, right? I am recording. So today what I thought we would do is move into what for some of you will be a review of matrix operations. But what I'm going to do is I'm going to show them to you on the TI-84, but since not all of you have a TI-84, I'm going to show you some online calculators that I personally feel are even easier to use than a TI-84, and leave it up to you which you prefer. Okay, the other thing I want to do after we go over the basics of operations, since if you can get a calculator to do it, all you really need to understand is what's happening in the middle of the operation. What I'm going to do then is show you an applied problem using matrices, and what I want you to focus on is to understand the meanings of the rows and the columns in the matrix. Okay, so again, the focus is primarily on how do I apply this stuff to a business context, and you know, what good will it do me? In some respects, matrices are exactly like Excel spreadsheets. And like Excel spreadsheets, there's usually meanings to the numbers in the rows and the columns. Okay, so we want to make sure that we focus on that sort of thing. I'm going to begin by sharing my browser with you. Okay, and again, I want to begin, and I'll always begin at this point, show you where we are in the module section of our Canvas course. Remember, you want to navigate the course using modules, not assignments, okay? Because again, all of the content is put together the way you want to consume it here. You've got our online video sessions where I'll upload the recordings as well as any notes that I use. Then we have some videos on matrix operations and some web pages on matrix operations. What I'm going to be using today are the matrix operations notes. You'll see one of these notes files for each one of our live online sessions. So if you want to look at those first, remember we talked about previewing last week. So you have some idea of what we're going to talk about before we actually get into the course meeting itself. So this is what I'm going to be working on, but I'll have some additions to it as well, the application stuff that I'm going to share with you. Here is kind of a worksheet, not a worksheet, but a how-to file on reviewing how to enter matrices on a TI-84. You can use this as reference. This is not something that you're meant to read, but basically if you need to refer back to how do I do this again, you have it here. This is important. This is a link to the Symbolab matrix calculator, which is what I'm going to use as an online matrix tool. Remember, for those of you who don't have a TI, you still want to have a way to do these calculations without having to do everything longhand. After all, it's not 1975. Even though it's important for you to know how it's working so you can interpret the context of a matrix, I want you to get comfortable with either the TI or the Symbolab matrix calculator for computation. Okay. Again, for this week, here are the assignments. We've got operations on matrices right here. This is the homework for today. And again, if I didn't mention it last time, I'll say it now. It's probably a good idea to take a look at the homework right after or sometime during the day of our class session. If you wait until Sunday to take a look at the homework, things are going to be kind of hazy by the time you do that. So try to do a little bit of the homework each day rather than waiting for Sunday to do all of it. Okay. So I'm going to begin by opening these matrix operations notes. And again, as I mentioned to you before, it takes me a bit to get this working on my tablet. So again, please be patient while I get this working. Right, and let me share that content with you. All right, so now everybody should be seeing my notes 1.3 matrix operations, and let me open up the chat just in case anybody has comments while we're moving along. So again, if you're having trouble seeing matrix intro and operations, please either speak up or put that in the chat. Okay. So all of the, okay. There's a question in the chat about exams. Okay. Your exams throughout the semester will be in more, except for the final, which is in Canvas. Again, we'll be doing reviews for these exams, so not to worry. Again, there's really no way to do paper exams in an online format. So we're going to be using the tools that we have at our disposal. Not to worry. What I'm asking you to do is to upload work, okay, so I can actually see your work and award you partial credit. Anybody else have any, before we get started, any other questions about the course? I want to make sure you have an opportunity to ask those while you're here. Okay. And again, let me just say this. If you have issues, whether it's technology issues, whether it's issues finding things in the course, as well as issues with the math, please speak up. You're always welcome to email me and ask me those questions. Okay, don't feel like you're doing this all on your own. Okay, I know this is an unusual situation, and the whole virtual thing is new, and you didn't sign up for that necessarily. But let's try to make it work, okay? And the best way to make it work is to reach out when you have an issue, okay? So kind of to review, matrices are arrays of numbers, okay? Kind of like a spreadsheet, okay? They're represented in somewhat different array of ways. So you may have seen them most frequently with these square brackets, like these first two examples. But please realize they're also represented with curved brackets that kind of look like giant parentheses. So if you see an array of numbers in curved brackets, it's a matrix. Okay, so there's alternative notation. Why is there alternative notation? That's a history question, and it has to do with the fact different people were working on these at different times, okay, when they were first invented, and different people came up with different notation, and it survives to this day. Okay, so that's kind of why. How do you describe a matrix? Well, a matrix has a property called its dimension. Okay, you'll notice a matrix has what are called rows, which are these horizontal lines of numbers, right, across. And it also has columns, which are the vertical array of numbers going up and down. Okay. So dimensions, the dimension of a matrix is a combination of its rows and columns, okay? So when you talk about a dimension, you're going to talk about the number of rows and the number of columns, okay? So the first number in the dimension of a matrix is the rows, and the second is the number of columns. Okay, so you would say an n by m matrix, okay, has m rows and n columns, okay? So again, just remember this little time sign in the middle is read as the word by, okay? And the rows always come first, the horizontal number of them. So if you're taking a look at this matrix here, in this example, we've got 2 rows, and we've got 1, 2, 3, 4 columns. So this is a 2 by 4 matrix. Okay, this matrix over here has 3 rows and 3 columns. So it's a 3 by 3 matrix. A matrix where the number of rows and columns are equal is called a square matrix. Okay, and they have some, we'll see those when we talk about inverse matrices. Okay. So again, that's just a review, okay? Now, when you walk through a matrix, okay, you've got elements. So for example, here in this matrix, each one of these numbers, -5, 4, 3, these are all called elements of your matrix. Okay, and they have a certain position in the matrix. Okay, this is important if you're doing any matrix operations by hand, or if you're actually writing software to do matrix operations, you have to know this. Okay, so basically the way you find the address or the way you specify a location in a matrix is with a subscript. Okay, see this example down here. These numbers, 1, 1, 1, 2, 1, 3, these are all telling you, okay, where these entries, and the A just corresponds to any number you want to put in here. It tells you where it is. The first number in the subscript tells you the row. So you'll notice here, all of these elements have a 1 as the first position. All of these elements have a 2. All of these have a 3. And all of these have a 4. So the first number in the subscript tells you the row, okay? And the second subscript, okay, tells you what column. So you'll notice here in the first column, the second number in the subscript is all 1. Here in the second column, the second subscript is a 2. And here in the third column, the subscript is a 3. Okay, so if you're talking about the element 3, A of 3, 2, A sub 3, 2, that would be in the third row in the second column. So here would be row 3, and here's column 2. Okay, this becomes important, okay, because a lot of the matrix operations, all of the matrix operations, tend to work element by element. Okay, so you have to understand where things are in order to be able to do operations on them correctly. Okay, also, these are important from an application point of view, since the meaning of the rows and the meaning of the columns in an application problem are important. Okay, so any one number at a particular location in the matrix has a business meaning, depending on the row and the column that it's in. Okay, so let me stop here and ask if there are any questions about dimension. Any questions about dimension of a matrix? Okay. Again, I'm assuming you've seen all of this before in college algebra, but again, it may be hazy, so our review wouldn't hurt. Special matrices, so what are those? Matrices with only one row or only one column are called vectors. Okay, here's the word right here. Right? Vectors turn out to be really important in subject like physics or statistics. Okay, in physics, vectors might have to do with, velocity in a particular direction. In statistics, a vector might be a certain subject in a statistical trial. Okay, so here are examples of a row vector, and here's a column vector. Okay, so again, we're just kind of going through terminology so you understand when we're talking about things like dimension or vectors, you know what those words mean. Okay, at the beginning of each section, I'll try to make sure we spend some time doing vocabulary. All right, here's the first operation we're going to talk about. Okay, and it's called transpose. Okay, and this may seem kind of pointless to you right now, but when you're actually doing algebra with matrices, and yes, that's a whole field of mathematics called linear algebra, sometimes it's important to interchange the rows and the columns in a matrix to make an operation work. Okay, so here is an example. And notice that the way we've described this, we're saying if matrix A is this matrix, okay? So how do we name matrices? We typically name them with capital letters, okay? A lot like naming sets, which you might have seen before. Okay, so this is matrix A, and it saves me from having to rewrite the whole matrix out every time I want to talk about it, okay? So here's matrix A. It has this first row, this second column. If we transpose it, here's the word, transpose, and there's an operation with a superscript, kind of like an exponent, but it's not an exponent. It's a capital T. What that says is take each row in the original matrix and make it a column. So you can see here, row 1, 2, 3 becomes column 1, 2, 3. Row -5, -4, 0 becomes the second column. So we've also changed the dimensions, okay, from this matrix had 2 rows and 3 columns, okay, into a matrix with 3 rows and 2 columns. Okay, so the transpose has also changed the dimension on the matrix. Okay, I can show you where transpose is on both your TI-84. Okay, we don't really need it yet, so I'm not going to worry about it too much right now. And I can also show you how to do it in Symbolab, in the Symbolab matrix calculator. It's real easy. You just type the word transpose and then enter the matrix. Okay. But again, we don't need transpose right now, so I'm going to kind of hold off on it for a minute. Okay, what I want to talk about are actual, what you would think of as arithmetic operations. Okay, so what are those? Those are adding, subtracting, multiplying, dividing. Okay, and it turns out that you can do these on collections of numbers, just like you do them on one single number. Okay, again, remember, if your matrix, if your collection of numbers represents something, then it might be really important to be able to add things in there, multiply everything in there by a certain number, or even multiply 2 of these together. Let me give you an example. Suppose you have matrices that represent inventory in various warehouses, okay, that your company owns. If you want to know your total inventory, well, what do you have to do? Well, you have to add the quantities that are in each warehouse. But then again, each row may represent different particular products you have, and the columns may represent different colors or sizes of those products. So let's say you're selling furniture and you have a medium-sized couch. Well, if you want to know all of the medium-sized couches in all the warehouses, that's going to be a particular element in the sum of all of your warehouse matrices, okay? So basically, I'm just trying to give you an idea of what you could use this for. And you probably have seen similar applications in spreadsheets where you're adding quantities across maybe multiple sheets in an Excel workbook, okay? Let me just stop and pause here because we're going to be using Excel in this course. And let me just ask in the chat, how many are comfortable using Excel? Now, by that, I mean, you know how to enter formulas in Excel. You're comfortable using what's built in with Excel. Not that you're necessarily an Excel expert, but how many of you are comfortable? Just type yes or no in the chat. Okay, please take a moment to do that. Okay, so take a moment and just type a yes or a no to answer my question. How many of you are comfortable using Excel? All right, so that seems like the majority of you. That's good. Okay, and don't worry, the few of you who were brave enough to answer no, we'll go through some quick, how to get you up to speed with that. Please realize, as business people, right now anyway, Excel is pretty much the gold standard for spreadsheets, and it's important to be at least comfortable with it, even if you're not an expert. Okay, so let's talk about adding and subtracting matrices. And again, in order to be able to do this, the matrices must be the same size. That means have the same number of rows and columns. Okay, so when we're talking about the size of a matrix, we're talking about its dimension, and that's what we're saying here. Now, again, to add or subtract two matrices, you do them element-wise. Okay, what does that mean? That means you take the A sub 1, 1 in the first matrix and you add it to A sub 1, 1 in the second matrix. Okay, so you do them element-wise. So here's two examples. I have this first matrix A, okay, and a second matrix B right here. And in order to add them, A plus B, okay, I just take the first element here, 3, and add it to the first element in the second matrix. And you can see that right here. 3 plus -2, that's going to give me the positive 1. And it winds up in the same position in your sum matrix. So both of the things you're adding, both the matrices you're adding or subtracting, okay, as well as the matrices that you're winding up with, your sum matrix, they're all going to have the same dimensions. So notice here, everything is 2 rows and 3 columns, right? So everything is 2 by 3. And this is also 2 by 3. Okay? The same thing would be true if you wanted to find A minus B. Okay, the only difference is you would have to be subtracting instead of adding. So you'd have 3 minus a -2 in this first column. Okay, everybody see the difference? Here there's a plus sign, here there's a minus sign. Now, before I go on and do this by hand, okay, because again, there's no reason to do it by hand. We have calculators. Let me show you how to do the sum on the TI-84, and then I'll show you how to do the difference in Symbolab. Okay, so is everybody okay if I show both calculators? Okay, you okay if I show both calculators? That way you can choose which one you want to use. Okay? All right, good. I'm glad you're flexible. So here's the TI, and again, I have to share it with you first. So let me share that content. All right, so now everybody should see a TI calculator, a TI-84 Plus on the left-hand side of the screen. Okay, let me turn it on, clear it. Now, if you remember, matrices in this calculator are here on the inverse key. You can see it right here. It's x to the -1. Okay, that's called an inverse. Okay, above it is the word matrix. Okay, remember how the TI works? It has multiple menus on each key. Okay, so this key actually has 3 things associated with it: an inverse, which is the key itself, the matrix menu, which is blue, so that means I have to hit second matrix, and then a green D. So if I want to store something in variable D, I'd have to hit alpha and then x to the -1. Okay, so there are these 2 keys up here on the left that control which one of the menus you're getting to on each key, right? So I'm interested in matrix right now, so I'm going to hit the blue second, then X inverse, and I get into my matrix menu. Okay, there are 3 menus at the top. The first one is names. Names is just used when you want to put the name of a matrix in your calculator window, okay, to do an operation on it or to display what's in the matrix. Okay, math, I'm going to arrow over to that. These are all matrix operations. You'll see this little superscript T for transpose. Remember, we talked about transpose briefly. So here's what you would use to transpose a matrix. Okay, and there are a whole bunch of other things that you probably don't know what they mean yet unless you've used them already. And then the last menu is your edit. Okay, this is where you actually put data into the matrix. So I'm going to do that here. I'm going to select matrix A to put the information from this matrix over here that I have right here. right? The first thing I have to do is put the dimensions in. So I'm going to say 2, enter, 3, enter. Okay, and notice the calculator will fill it out with zeros. Check to make sure it's the right shape, okay, before you enter the values. And then the calculator, as you're typing, will go across the rows and then drop down to the second row, the third row, and so forth, right? So it fills it row-wise. So I'm going to type in 3, then 4, then 7, and you can see I'm in the second row now, 0, -8. Remember, negative numbers, you're going to use this leading negative sign down here, not minus. Okay, minus takes 2 operands, leading negative only 1. Okay, and then a 5. All right, so there's my first matrix. My recommendation to you is some students try to navigate once they're inside a matrix. That usually results in you having garbage in your matrix. So I tell my students, even though it takes a while, quit out of your matrix and come back in to do more operations. So I'm here in my last row. My matrix looks good. I'm going to quit. See it up here? Second, quit. Okay. And then to enter matrix B, I'm going to go back into matrix. Go back over to edit. You can see here's matrix A is in there now. And then go down to B and hit enter. That's also a 2 by 3 matrix. So put in its dimension first, and then put in the values, which are -2, 1, 4, -3, 2, and 9. Okay, and then just double check that it looks correct, which it looks correct. And then quit out of here. All right, so now what I wanted to do here is to first figure out the sum. Remember, here's the sum, A plus B. And the TI-84 is smart enough to know, even if I put matrices in an operation and I'm using the regular plus sign, it knows it has matrices and it knows how to do matrix addition. So here's how I add. I'm going to go back into matrix. And I'm going to pull, notice that I'm in the names menu now, and I'm going to pull matrix A, put that in my window. Okay. If I hit enter now, it'll just dump the contents of the matrix, but I want to do an operation. So I'm going to put my plus sign, then go back into matrix, go down to matrix B in the names menu and put that there. So now I have it set up to do an addition of 2 matrices. All right. If I hit enter, I get the same matrix that I have here in my notes. See it? 1, 5, 11, -3, -6, 14. Everybody okay with that? Okay with the TI? Again, this is if you have a TI. Anybody have questions on it? Okay, I know some folks initially are a little intimidated by a TI calculator and then they fall in love with it and they want to use it. So I want to make it comfortable for you. Okay, but just in case, let me minimize my TI. And I'm going to go back and I'm going to show you the Symbolab matrix calculator. Again, remember, this was in our week 2 module in our class. Okay, so let me just hide this for a moment. Okay, here's the link to it right here, week 2 Symbolab matrix calculator. And then again, I have them down here at the bottom of the course. Remember, I have all of the tools in one place down here to make them a little easier to find. They're after week 15, after the final exam. See online tools and calculators? Here's unit 1, which is what we're in. Here's Symbolab matrix calculator. Okay, so if you're like me and you don't like searching through to find things, you like everything in one place, okay, that there's less to worry about that way. Here's online tools and calculators. All right, so I'm going to go to that calculator and show it to you. Okay, Symbolab's a really powerful math engine. Okay, and this is the matrix calculator in Symbolab. So what's cool about this calculator is it kind of eliminates a lot of the typing and things that I have to do. Okay, so for example, I don't need to remember what menu matrix is on, how to get there. I just need a link to the matrix calculator. And then you just pick the size. Okay, so remember these are 2 row, 3 columns. So I want a 2 by 3 matrix. So this is the size. Okay, and it just pops up a template for me to put the numbers in. Okay, and the numbers could be put in using your keyboard. And again, on your keyboard, there's no distinction between a minus sign and a leading minus sign. Okay, so that makes this calculator a little bit easier to use. Okay, you don't have to remember, okay, is it leading minus or is it minus? The leading minus sign is when you've only got one number. Subtraction is when you've got 2 numbers. Okay, so that's only important on a TI. Here, we're good to go. So I'm putting in my values here. Okay, and then it's 0, -8, and the last one is a 5. That's matrix A. All right, and then I'm just going to put in a plus sign from my keyboard. And then I need another 2 by 3 calculator, okay, which is -2, 1, 4. Here's matrix B going in, -3, 2, and 9. And then all you do is press go. Give it a minute. And here's your sum matrix, okay? And again, you can see it's exactly the same matrix that we got in the notes. And here's another thing I like especially about it. Suppose instead you said, oh, wait, I wanted the subtraction. I didn't want an addition. Just go back up into the line where you typed, put a minus sign, hit go, and then you get the difference of the 2 matrices. Okay, so here's the subtraction. And here's the difference, okay? Just remember, look down to the word solution, okay? And again, just so you are aware, this Symbolab used to be a lot more of an open tool in the sense it would show you things for free, okay? Nowadays, sometimes if you say show steps, okay, they're going to tell you, oh, you want the premium version, okay? So remember, we're using it for free. So we're kind of getting the overview, but that's pretty much all you get with a TI anyway. So it's not like we're losing a lot of functionality. So I personally like this calculator. I think it's a little easier to use, but let me just see if anybody has questions. Anybody have questions on Symbolab? Okay. Pretty much pick the size and type in your stuff. And just you put the operation in there. Okay, good. All right. Going to go back to the notes then if there are no questions. All right, and let's talk about multiplying matrices. Okay, multiplying matrices is really helpful if you have, say, information about inventory in one matrix and then pricing information in a second matrix, and you want to know what's the value of your inventory on hand. Okay, some of you may have done this in a spreadsheet, and the operation is pretty similar to what you do when you multiply matrices. Okay, so it's a little bit more complicated, and it's only a little bit more complicated because the sizes don't need to be equal, but they need to be compatible. Okay, and what do I mean by that? If you're going to multiply A times B, then the number of columns in A has to match the number of rows in B. And the reason for that is how matrix multiplication works. So let's do this really quick. Okay, I'm going to show you here what I'm talking about. Suppose A is 2 by 3, okay, and B is a 3 by 4. Okay, so here's what you're thinking. Okay, A times B. Okay, and I'm using the times symbol as a star. Okay, but again, you can use a dot. You can also use a regular times symbol. Okay, whatever you want to use here. Okay. All right, so A, let's say, is a 2 by 3, and B is a 3 by 4. Okay, put them next to each other like that. And then what you want to notice is these inner dimensions match. Okay, so again, the first 3 is telling you the number of columns in A, and the second 3 on the B side is telling you the number of rows in B. These two must match. Okay, and your product, AB, it turns out, will have the dimensions on the outside. Okay, so see these? You've got a 2 and a 4. Okay, those are going to be the dimensions of your product. Right? So basically, if you can just put the dimensions of the 2 factor matrices next to each other, these 2 middle numbers have to match in order for it to work. Okay? And your product matrix will have the remaining dimensions. It'll have the number of rows in the first matrix times the number of columns in the last matrix. Okay? Now here's an interesting question. Would you be able to multiply them in the reverse order, like B times A? Well, let's assume they have the same size. And this was 2 by 3. What do you think? Will this work? I'm asking a question in the chat. Okay, will this work? What do you think? Okay, I have 2 people signing in, and how about the rest of you? What do you think? Will this work? Okay. Good, good. No, it won't. Okay, because we have a no match. Okay, no match. Okay, and again, it's because the number of rows in the second matrix aren't matching the number of columns in the first. Okay, so basically you can see that here. Okay, and I've showed you that with my picture. Now this brings up an interesting thing you might not realize. If you're just talking about numbers, not matrices, you might remember that 5 times 7 is 35, and 7 times 5 is also 35, right? This is sometimes called the order, or if you went to school a little earlier, commutative property. Of multiplication. It turns out addition also has this property with numbers. But what about matrices? Okay, is matrix multiplication commutative? So what I'm asking is does the same property that holds for numbers work for matrices? Okay, what do the rest of you think? Okay. How about a few more people? I'm asking you, does the order you multiply matrices in matter? Or is it like numbers where order doesn't matter, so it's commutative? Okay, good for you. Okay, so now my question is, why not? Okay, so basically matrix multiplication is not commutative. And again, I'm having trouble seeing the chat in its entirety. Okay, why do you think? So I'll say matrix multiplication is not commutative. So what do you think? Why is that not the case? What do we have to worry about with matrices that we don't have to worry about with numbers?
So I think we worry about the round columns in the matrix is not worried about the numbers.
Right. Okay. So basically the problem is the matrices, the order is yes, it has to do with that too. But basically it's because we have to consider the size of the matrix. That's a consideration. Okay. And numbers, we don't have to worry about that. A number is a number. Okay. And the order. Yes. Okay. So it's important to pay attention to this. If you try to do this on a TI-84, you get what's called a dim mismatch. Okay, it's important when you get an error on the TI-84 calculator, pay attention to what kind of error. Okay, and a lot of folks just look at the word error and they're not sure what to do next. But underneath it, it'll say dim mismatch, and that usually means you're trying to multiply two matrices that will not multiply, okay? All right, so let's go through this once by hand, and then we're going to use calculators to do it from here on in, okay? So I have two matrices, all right? What are the sizes on both of these matrices? I think you can tell they're the same size. So what are the sizes on A and B? What are the sizes? Somebody want to either type in the chat? Okay. Miguel's saying 2 by 2. Does everybody agree with that? Yep. 2 by 2. 2 by 2. Good. And you can see, again, these inner dimensions match. So I can multiply the two matrices for sure. Yes. Okay. And then here's what's important. The product AB will also be, if you look at the outside dimensions, will also be a 2 by 2 matrix. That's important, especially if I'm going to build it by hand, because I want to know what my final matrix looks like. Okay, and I know it's going to have 1, 2, 3, 4 entries in it, a 2 by 2 matrix. Okay, I'm going to erase my lines, but I just wanted to show you why people worry about, the dimensions of the answer. Okay. So what I need to do is to multiply the elements in the first row of A, that's the 0 and 1, by the first column in B. So that's going to look like this. Okay, so see if you can follow what I'm doing. I'm going to multiply the 0, okay, by this. Okay, so 0 and 1. Let me do the picture a little differently. And like this. All right, 0 times 5, and then switch the colors 1 times 4. Okay, that probably makes more sense. Okay, there's the first product, and then here's the second product. All right, so you go across the row in the first matrix and then multiply down the column. So the things that are in pink, okay, get multiplied. The things that are in blue get multiplied, and then you add them together. Okay, now that's, again, first row, first column. It puts the entry in, entry 1, 1 in the answer. Okay, now I'm going to stay going across this row, but I'm going to move to the second column. Okay, so that means I'm going to multiply the 0 by the 7, and then I'm going to multiply the 1 by the negative 1. Okay, and that's going to go, notice it's going where these two rows would cross if I overlaid them on the product. So first row, second column. It's going to go in the 1, 2 entry over here. Okay. So I'm just showing you 0 times 7 plus 1 times negative 1. Okay, everybody see that? All right. Then I've done everything on the first row here. Okay. So I need to move down a row in my first matrix. Okay, so I'm going to multiply the 2, and I'm going to go down the first column again. All right, and this is going to be down here in the 2, 1 entry. Okay, and then again going across here and down here. Okay, so that's going to be 2 times 5 plus 3 times 4. Okay, still going to stay going across the second row, and then this time I'm going to go down that second column in the B matrix. So I'm going to get rid of these highlights and change those. Okay, so now I have 2 times 7 plus 3 times negative 1. Okay, and that's pretty much how you navigate through. Okay, I realize they wanted you to just do the first entry, but now they're saying add the products together. So this would be 5. 0 times 5 is 0. Plus 1 times 4 is 4. Okay, so this would be a 4. This is 2 times 5 is 10, and you can see these down here. Plus 3 times 4 is 12. That's 22. 0 times 7 is 0. And 1 times negative 1 is negative 1. That's right here. So that's negative 1. And then 2 times 7 is 14. 3 times negative 1 is negative 3. So 14 minus 3 is 11. Okay. So that's the process for doing it by hand. Okay. Now, the only time where it's important to understand how this works is, again, in applied situations. Okay, understand so that way you're setting up your matrices or even your spreadsheets correctly. Okay, let's show how to do this on the TI. Okay, really quick. Okay, so my TI fell asleep, so I'm going to turn it on. All right. I want to get rid of what I have in matrix A and B because they're totally different sizes. You can see that here on my screen, totally different sizes than what I had before. So how do you quickly clear the TI-84 so you don't have to, manually go in and type over a matrix? That's kind of a bad idea because particularly if your matrix that you're typing in is smaller, you may leave junk in the matrix and then you'll get incorrect answers. So here's how you clear out matrices. See down here above your plus sign, you've got this mem word. This is your memory management for your calculator. So I'm going to hit second plus, and it's going to bring me into this menu. Okay. And it kind of like clears things. Okay. Clears things nicely. I'm going to go to memory management, delete the second entry. And then it tells me all the things that I could clear out. Real numbers, complex numbers, lists. I'm going to go down to matrix. And it shows me I have 2 matrices, and this is the amount of storage in the calculator they're taking up. I don't really care about that. Okay, but I do want to delete A and B that are in there. So you notice there's an arrow pointing at A. I'm just going to hit the delete key. Now it's gone. And there's an arrow pointing at B, hit the delete key, and we're good. Okay, and now I can quit out of memory management, delete. Get comfortable with this quit key up here. This is how you get out of any place that you don't want to be in a hurry. Okay, so second mode quits me out of there. Now I can go back into my matrix menu, which is second, inverse, And you notice there's nothing stored anymore. I cleared it out. So I'm going to quickly go in here and put in matrix A, which you told me was 2 by 2, and put in those values, which were 0, 1, 2, and 3. I'm going to quit out of here, go back in to matrix, edit matrix B, which is also 2 by 2. And I'm going to put in those values, which are 5, 7, 4, and negative 1. Okay, and quit out again. Now again, in a TI, in order to multiply things, you don't really need to use the multiply key, although that would work. All I need to do is put matrix A and B next to each other, because in algebra, if you put two variables next to each other, it means multiply. And these matrices are functioning like variables, right? They've got names and they've got values in them. Okay, so here's the way I'm going to multiply them. Go into your matrix names menu, put in A, go back into matrix names and put in B right next to it. Okay, see, no operation symbol needed. The calculator knows I mean matrix multiplication because A and B are matrices. All right, and you can see I got the same value that we got by hand. Okay, you do this exactly the same way in Symbolab. You put a 2 by 2 matrix next to a 2 by 2 matrix and then hit the go button or whatever that is there, and it will multiply the two matrices. Okay, so okay with using multiplication. Everybody okay with this on either of the calculators? Again, Symbolab works very similar to this, but it's just a lot more easy to type in the matrix because I don't have to navigate to a special menu. It's right there. Okay? All right. All right, let's take a look at multiplying the reverse way, B times A. Okay? So again, you can see not only does dimension matter, in this case that will work, but the order of the elements in the two matrices, which I think Daisy said earlier, isn't the same. Okay, so you can see even though this is possible, I'm going to get something different. All right, so let's try B times A in Symbolab, just so you're comfortable doing this. I'm going to clear this stuff out, just highlight it and backspace over it. And I'm going to put 2 by 2, which was 0. This one, whoops, 0, 1, 2, 3. Okay, and put the other, that's matrix A. And now I want to multiply B ahead of it instead of behind it. So put a 2 by 2 ahead of it. Okay, and again, matrix B was 5, 7, 4, and negative 1. And then hit go. And you can see if you look at this, we've got different numbers. Okay, the first one was 4, negative 1, 22, 11. And now I've got 14, 26, negative 2, 1. Okay, so switching the order gave me a different product. Okay, this is an important feature of matrix multiplication. And what you want to say here is, okay, here's what we got. This is not the same result. Okay, and that means matrix multiplication is not commutative. Okay, so there's two things you've got to worry about with the commutativity. One is the size of the matrix. May make it impossible to multiply it in the other order. And the second thing is, well, you're going to get a different answer because the stuff is in a different order in the matrix. Okay, so before we launch into application problems, what I would like you to do is to try these. Okay, so I'm putting these up here, and I'm saying try these. Okay, so again, what I want you to do is either use your TI-84. Oh, I didn't show you where transpose is on the TI-84. Now let me show you really quick. Okay, your transpose key is on your matrix math menu. So let's transpose matrix A. I'm going to go into matrices. I'm going to pull up matrix A. And then transpose is on my matrix math menu. So second matrix, go over to math, and it's the second entry. Okay. So if I transpose it, it's just going to switch the rows and columns. Okay. So instead of, remember, it used to be 0, 1, 2, 3. Now it's 0, 2, 1, 3. It just, here's the first row, here's the first column. So again, it's on your matrix math menu. Okay, in order to transpose in Symbolab, just type the word transpose. Okay, so what I would like you guys to do is please try these. Okay, type done when you are finished. Okay, this gives you the opportunity to try out your favorite matrix calculator, either the TI or Symbolab. Give it a shot, folks. Actually try them. That way you can ask questions before you have to use this stuff for homework. Okay, so we're just doing these four. Sorry. It will maybe take 5 minutes or so. We'll take another minute or so for some more folks to be finished. Okay. Okay, folks, let's come together. I realize that not everybody is finished, and that's fine. I'd just like to make a suggestion to you is that when you come to the online classes, try to have our Canvas course open in one of the tabs so you can get to, say, the online calculator if you don't have a TI-84. And I will usually leave up in my meeting tab what it is that I'd like you to try. It's important to actually give the stuff a try and notice if you're having trouble, notice where you're having trouble. Okay, it's more important to be able to pinpoint what you're struggling with than just say, I don't get it or I'm having a problem. Okay, because usually it's one small little thing that if you ask, or if I can help you, we can work through that. All right, and it's just one tiny little thing that you need to understand. So make a note of what it is you're struggling with. Are you having trouble entering things into the calculator? Are you having trouble locating where you have to enter it in? Those are two different questions, so it's important to know the difference, okay? So I'm going to do this first transpose by hand, okay? It's a transpose. Before I do any of them, though, I'm going to put the size of each matrix underneath. This matrix has 2 rows, 3 columns. This one has 3 rows, 2 columns. This one has 2 rows, 3 columns. And even though we're not using D, it's a 3 by 2, okay? And E is how many rows? 3 by 1. I'm sure you'll recognize E is a vector, okay? Even though we're not using it in any of these examples, okay? So to transpose A, all I need to do is to switch the rows and columns. Okay, so the first row, 253, becomes the first column. The second row, 10, negative 4, 1, becomes the second column. Okay, really as simple as just doing that. Okay, so transposes are fairly easy to do by hand. If you wanted to use the Symbolab, I'll show the Symbolab calculator. Okay, just so you have something that you're comfortable with. Let's see if I can get to that. Okay, so here's my Symbolab calculator. I'm going to type in the word transpose, and then I'm going to type in matrix B, and matrix B I said was a 3 by 2, and then I'll put in 3, 1, 5, negative 6, 3, 2. And then just hit go. Okay, and here it is transposed. Again, you can see 353 is now the first row. 1, negative 6, 2 is now the first row. Okay, so that's how you do it with the calculator. Okay, the others, again, let me just put that in here really quick. All right, the next one is a multiply. It's A times B. Okay, again, that's easier to do with Symbolab. So let me go back there and do A times B. Okay, so my first matrix was a 2 by 3. And I'll put that in. I should have left B up there. So 2 by 3. And then this is 10, negative 4, 1. Oops, something squirrely. 2, 3. And again, since this is a 2 by 3 and B is a 3 by 2, okay, we can again see that the number of columns in the first equal the number of rows in the second. So the matrix is, it's possible to do a matrix multiply. Not sure why that keeps happening. I'm probably fat fingering something, but I'm not realizing I'm fat fingering. 5, negative 6. And 3, 2. All right, and then just hit go. And hopefully everybody got 40, negative 22, 13, 36 as the answer. Again, I'll make sure that's in the notes. Okay, and the last one was A minus C. I'm going to try to be smart this time and leave matrix A in there. You'll notice matrix C has the same dimensions. It's a 3 by 2. So I'll be able to subtract it. Let me put another 3 by 2. Oops, wrong one. It's a 2 by 3. Sorry. This is 2 by 3. And if I'm doing adding or subtracting, the matrix dimensions have to match exactly. All right, so this is a 3, a 4, a negative 2, and a negative 5, 6, and 8. Okay. And hopefully everybody got this answer, 5, 1, 5, 15, negative 10, 7. Okay. Okay, with using Symbolab for matrices. Okay, with using Symbolab to do matrix operations. Okay, good. All right. What I'd like to take the rest of the time we have to do is to show you an application problem and to show you how you use the meanings of the rows and the columns to help you solve an application problem. Okay, so the one thing I'm adding here, we're still using dimensions and all that good stuff, but what we're talking about now is what do the rows and columns mean in a matrix if they apply to an application? Okay, so I'm going to go back to sharing my notes with you. Again, if I don't fill in everything while we're in class, not to worry, I will make sure it's filled in the notes that I upload. Okay, so for example, the answers to the problems I asked you to try. Right here, 40, negative 22, 13, 36, and this one over here, 5, 1, 5, 15, negative 10, and 6. Okay, so if I don't actually fill them in while we're in our class, not to worry, I'll make sure everything gets filled in. Now there's another page of examples, okay, which I'd encourage you to try on your own with your calculator. but I will definitely upload solutions to these as well, so you can see them. But let's actually take a look at this problem. Okay, so this is an application in cost analysis. Okay, and again, some of you who are familiar with using spreadsheets might remember seeing things like that with an Excel application. So I have the Mundo Candy Company, and they make 3 types of chocolate candy, something called a Cheery Cherry, Mucho Mocha, and Almond Delight. So they make 3 different kinds. The company produces products in San Diego, in Mexico City, and in Managua, Nicaragua, using 2 main ingredients, chocolate and sugar. Okay, so let's take a look at some of the information we got here. We've got 3 products, okay? We've got 3 production locations, and we have 2 main ingredients, okay? All of these things are going to become dimensions in matrices, okay? So each kilogram of cherry requires half a kilogram of sugar and 0.2 kilograms of chocolate. Each kilogram of the mocha requires 0.4 kilograms of sugar and 0.3 kilograms of chocolate. And each kilogram of almond requires 0.3 kilograms of sugar and 0.3 kilograms of chocolate. Put this information into a 2x3 matrix, labeling the rows and columns. Okay, let's do that. And they want to call that matrix A. Right? If it's 2x3, that means it has 2 rows and 3 columns. Okay? So we have to figure out, all right, what is the 2 and what is the 3? So I'm asking you, what do you think the 2 rows will correspond to? What do you think the 2 rows will correspond to? Think about this. I got 3 types of candy, and each requires 2 ingredients. Okay? Yes. Okay? Good for you. All right? So it makes sense to use the 2 rows to be the 2 ingredients in the candy. All right? So I'm assuming there's more, in most cases, more sugar than chocolate. Yeah, in most cases. So I'm going to let this be sugar and let this be chocolate. Okay, so my first row is the amount of sugar in each candy, and the second row is the amount of chocolate. Well, then that leaves the rows to be what? Okay, so what do the columns correspond to? What do you think the columns correspond to? Yep, the types of candy. Good. So let's call this one cherry, mocha, and almond. Okay, so now you have a 2x3 matrix, right? So you've got size, but it's important to remember this is ingredients and this is candy type. Okay, so not only do you have the numbers on the dimensions, but you have a meaning associated with the rows and the columns, yeah? And now I can put the values in, okay? So I want the sugar for cherry is 0.5, the sugar for mocha. And again, to make this easier, you can actually go back and take some strategies from critical reading. You can say, okay, so here's the sugar for the first, the cherry. Okay, and then I can highlight in a different one the sugar for mocha, and highlight in a different one the sugar for almond, right? So I have the numbers highlighted. Don't be afraid to use strategies that you know from critical reading when you're reading an applied problem in any subject, whether it's math or econ or psychology or anything like that. Okay, those skills are meant to be translated across the board. Okay, then the next thing I might want to do is I might want to look at the amount of chocolate in each of these. So here's the cherry. Here's the mocha. And here's the almond. Okay, so let me put those in the chocolate row. Okay, and again, if you want to put, if you don't like those decimal points hanging out there, you can put a 0 in front just so you know that you've got less than a kilo of each of these ingredients. All right, so there's your matrix A. Okay, now let's talk about cost. So you have 3 different manufacturing sites. The cost of your supplies is going to be different in each place. Okay, for example, if you're down in Honduras, maybe sugar is more expensive because most of it gets exported. Who knows? Okay, so a kilogram of sugar is $4 in San Diego, $2 in Mexico, and $1 in Managua. It's actually the reverse. Okay, it's cheaper near where it's produced. Okay, the cost of a kilo of chocolate is 3 in San Diego, 5 in Mexico City, and 7 in Managua. Okay, so you've got prices for each one of your ingredients. So they're saying put the information into a matrix called C in such a way that when you multiply your matrix from part A, you get a matrix that represents the ingredient cost of producing each type of candy in each city. Okay, so let's take a look at what this is asking. Okay, we want to build matrix C. Okay, and again, we've got 2 ingredients and 3 locations. So C can be either 2 by 3 or 3 by 2, right? So you can either, and 2 is going to be your ingredients, and this is going to be city. Well, this is going to be city, and that's going to be ingredients. Okay. So let's take a look at how we can do it. Okay. Now what they say is choose one. Okay. So if I need to multiply, okay, I want to make sure I get what as my answer. I want to get ingredients. Okay, that's going to be a 2. Then I want city, like that. Okay, so basically I can get ingredients, right, like that. But then it says the cost of producing each type of candy. So they don't want ingredients anymore. Okay, they want candy. Right, so what they want is a 3 by 3 matrix to be the answer. Okay, it's important to understand you want everything here is going to be costs, right? Because you've got the weight of every ingredient going into each candy, and you're going to multiply that by the price per kilo, right? These are in kilos, and you're going to multiply by price per kilo. So you're going to get money in your answer. But you've got to figure out how many rows and how many columns would I have, okay? So let me just, because we're running out of time, let's do it like this, okay? I'll show you how it works, okay? I can do my cities as my rows, okay? So my cities are San Diego, Mexico City, and Managua, okay? And then my ingredients are sugar and chocolate. Okay, so I basically want to put in the prices. Again, I can go through this section and highlight them the same way I did before, right? Like highlight the sugar in San Diego and the chocolate in San Diego. Okay, so in San Diego, sugar is $4. In Mexico City, it's $2. In Managua, it's $1. Chocolate is $3 in San Diego per kilo. $5 in Mexico City, $7 in Managua. So I have this, okay? This is a 3 by 2, okay? And the 3 are city, and the 2 is ingredients. Okay. Now, again, what's important to understand is the way you want to multiply this. Okay. So again, I want a 3x3 matrix because I want to know candy type and cost of doing it in each city. Okay. So you're looking at this and you're saying, well, if you multiply it like this, okay, AC, okay, this is going to be ingredient times candy type. This one's going to be city times ingredient. Okay, so this is 2 times 3. This is 3 times 2. Okay, will that result make sense? Okay, again, remember, I can do the multiply because these match. But then that means AC is 2 by 2, which is ingredient times ingredient. Does that make any sense? Or does the meaning of the rows and columns make sense? If I do it like this. Yet, yeah. No. Okay. Ingredient times ingredient doesn't make sense. But suppose I do it like this. Okay. C is a 3 by 2. Okay. And this is city. That's ingredients. Okay. A is a what? A is a 2 by 3. Okay. And that's ingredient times type. Okay. This will also work. Okay. But look at what your result matrix will be. Where you've got city by type. Okay, so you want to multiply CA, okay, because that makes sense as far as the meanings of the rows and columns. Okay, the point I'm trying to make with this example is it's not enough to just decide mathematically, can I multiply these two matrices? It's important to understand what do the rows and columns represent and will the product make sense? Okay, I could multiply A times C mathematically, but I get something that's garbage. It doesn't make sense at all. Whereas multiplying them in the reverse order will tell me, okay, each row will tell me, okay, first row is San Diego, second row is Mexico City, third row is Managua, and the columns, there'll be 3 columns. It'll tell me the cost of the cherry candy, the mocha candy, and the chocolate candy at each of my manufacturing plants. Okay? So again, without actually even multiplying this stuff out, okay, I can tell you that only this way makes sense. Okay? So if I were to go actually in and enter matrix A and matrix C in Symbolab and then multiply C times A, I would get prices, okay, for each of my products, for each kilo of my product. Okay? Does this make sense? Okay, let me ask you, does this make sense? Okay, do you have any questions? Anybody have questions on any of this? Okay. Again, so please be aware it's not enough to just make sure it's possible. Okay, actually, when you're doing an applied problem with matrices, don't just label the dimensions, label what they mean. Okay. All right. Not seeing questions. I'm going to come back to the meeting, stop sharing my screen. And I'm going to ask if you've got any questions on anything, including how to use calculators, anything in the course. Anybody have questions on anything?